this video, we'll explore the core data structures used in R. Understanding how R organizes data is essential before working with real public health datasets. We'll focus on vectors, lists, matrices, and data frames, and discuss when each one should be used. The most basic data structure in R is the vector. I'm sure you must be wondering, what exactly is a vector? Well, a vector is basically a collection of values of the same type. Vectors are commonly used to store measurements such as ages, counts, or laboratory results. Because all elements must be of the same type, vectors are simple, efficient, and widely used. Let's create a vector called ages. We'll do this using the C function, which stands for combine. This stores several numbers in a single object, in this case ages 25, 30, 45, and 50. Next, we can create another vector called cases. This also uses the C function and represents the number of cases corresponding to each age group. When we type ages or cases on their own, R prints the contents of those vectors so we can see what's inside. Next, we'll talk about lists. Lists are more flexible than vectors. Unlike vectors, lists can store elements of different types and even different data structures. This makes lists useful for storing complex outputs, such as results from statistical models. Many R functions return their results as lists, so understanding them is essential as you advance. Let's create a list called health_list. Inside it, we store the ages vector, the cases vector, and a text value called location. This is useful when you want to group related information into one object. When we type health_list, R shows everything stored inside the list. Next up are matrices. So matrices are two-dimensional data structures where all elements must be of the same type. They are often used in mathematical and statistical computations. While matrices are less commonly used than data frames in public health, they are important for understanding how R performs calculations behind the scenes. Let's create a matrix called case_matrix. This can be done using the matrix function. We provide the numbers first, then specify that we want 2 rows and 2 columns. R fills the matrix column by default. When we print the matrix, we can clearly see the values arranged in rows and columns. Data frames are extremely important in R. A data frame is like a table or spreadsheet. Each column represents a variable, and each row represents an observation. Data frames are the most common data structure for public health data analysis. Unlike matrices, data frames can contain different data types across columns. Most data sets you will analyze, surveys, surveillance data, and clinical data, will be stored as data frames. Here we can create a data frame called health_df. It has 3 columns: age, cases, and sex. Notice that unlike matrices, data frames can contain different data types, numbers, and text, all in the same table. When we type health_df, R displays the entire data frame in a neat table format. Finally, we use the str function. str stands for structure, and it shows us how the data frame is built behind the scenes. It tells us the number of rows, the number of columns, the data type of each column, and a preview of the values. This is a very helpful function when you're exploring a new dataset. And that's it. You've just seen examples of vectors, lists, matrices, and data frames, the building blocks for working with data in R. In the next video, we'll begin working with real datasets by learning how to import data into R from common file formats. This is where analysis truly begins. Subscribe to the channel to continue building your skills step by step. I'll see you in the next lesson.